incident that made it stop for more than a year.
Yes.
And this was, of course, a sign of bad luck. And there was another machine, the SSC, in Chicago. No, not in Chicago. In Texas, which was should have been bigger than the LHC in the sense that the beam of the SSC should have had 20 TeV energy per particle going around the ring, while in LHC it is 7 TeV, and this TeV stands for tera-electron volt.
Mm-hmm.
And this is an electron volt is the energy an elementary charge gets by going through a potential of 1 volt. And tera means 10 to the 12, so it means million. So a million. So in the LHC, when it comes to its big running, would be 7 TeV on 1 proton and 7 TeV, which means 7 million electron volt energy on 1 proton going against another proton with the same energy of 7 TeV, so that together they will have 14 TeV.
Yeah.
And there will be in the center of mass, in the collision, 14 TeV energy available in principle for producing new and interesting particles. But it is difficult to get it used all in an effective manner, but there should be good chance for producing a Higgs particle, which, for instance, could have, as I believe myself, 115 GeV.
So a tremendous amounts of energy here, obviously, that is being used in order to clash these particles together to kind of, I mean, I've heard in some circles that this could potentially, open a portal in terms of dimensions and things like this. That it could in some way upset the normal physics here on Earth, for instance. Have you heard about this? What's your theories about this?
Oh yes. No, there is in the superstring theory type of ideas. There is a proposal. Or there is the idea going that there should be extra dimensions.
Yes.
So one of the possibilities for interesting things to happen at LHC is that one could discover that instead of the usual number of dimensions of 3, we have, so to speak, 3 coordinates needed to fix the position of a point, up, down, east, west, or north, south. And instead of the 3, then in superstring theory, there is in principle 9 space dimensions and 1 time dimension. And therefore, there could very well be some extra ones. And then these models might make it possible to somehow see particles that signals that there are these extra dimensions. That would be called Kaluza-Klein particles. And there's also on the market some story that one could use this to make the mass parameter in gravity combined, gravitational constant combined with other parameters. That gives you can construct a mass which would be somehow the most fundamental mass and call the Planck mass. Mm-hmm. And this Planck mass unit, which is somehow suggestively the best unit you could have of if you should guess what is the natural mass unit in physics, that is a mass unit that is 10 to the 19 GeV. This is a mass of some sort of little salt corn or so. So it is a millionth of a gram or so. It's on a human scale a small mass.
Yeah.
But compared to the masses of the particles you can see at LHC, it's enormous.
Yeah.
Far too big. If you had a particle with that mass, you couldn't dream about producing it at LHC. Far too big. And the mass of the Higgs particle, which we expect it to have, we know the order of magnitude of it, so the order of magnitude we know would be about 10 to the 17, enormously much smaller than this Planck mass. And that is actually one of the very interesting problems. Why is the Higgs mass so small compared to the presumably fundamental mass?
Yeah. Huh. Any answers to that? Any theories about that?
Well, this is a scale problem, and well, I would of course claim that I have a model where we have a sort of answer to this, but that is that probably nobody will believe in. But in superstring theory, and there is an attempt to not completely solve that, but to partly solve that problem by trying to do that at least when I make corrections to this little Higgs mass, then I don't get it big immediately, but I just shuffle it a little bit and not a big bit. You see, if I get, even if I assumed that a fundamental parameter in the theory related to the Higgs mass was very small, then it turns that when you correct it a little bit and calculate what you should really see as the Higgs mass and the thing that you really know is small, then it would deviate a lot. So you would have to say that the parameter giving the Higgs mass should be adjusted not to be small, but to be big at a place where it would just, when being corrected, would be small. It sounds even more crazy that way, you see?
It does in one way.
And this last problem of shuffling it around by big quantities, this can be solved in the theories which have the so-called supersymmetry, which means in the theories of the type of the superstring theory. This is this aspect that gives the name super to the string theory, which is important for solving that problem.
I see. And you tell us a little bit about your model then, the model that you're developing.
I have a model. Of course, as you mentioned kindly, I am also a father, one of the fathers, although in some sense a bad one, for the superstring theory or the string theory.
Yes.
But I have a model which was the one you mentioned, came in New York Times, and this is a model which we announce as being the suggestion that the action is a complex quantity instead of a real quantity.
What does that mean?
Yeah, that's right. That would mean that I should explain what an action is. And an action is a quantity that is a function of a history of a system or of the whole world, if you wish. So you put in a history, and then, according to some formula, you calculate a number. And this is what one could call a functional. And this is a type of functional of a history that could be, for instance, the action. And this action is used very often by physicists to tell to their colleagues when they have a certain model or a certain theory. Because instead of writing down all the equations for how the forces and the accelerations and so on are in their theory, how the particles move around and what equations the fields obey and so on. Instead of doing that, they can write an action which is then a formal expression for how you calculate from a history this quantity, the action. And then by manipulating this action, in a certain mathematical way